So in this video, we're going to review the Exam 1 review content from Lecture 2. So the first question asks us to write a sentence to differentiate between syntax and semantic errors. Remember that syntax are the actual rules of the language. So if you have a syntax error, it violates the rules. And what that means in short is that the code won't work. The actual process for going from computer code to actual kind of machine level code that the microprocessor can understand in its instruction set architecture, kind of reflecting back on some of those concepts from lecture 1. But put simply, the process from going code you write to code the computer can use is either called compiling or interpreting, depending upon what type of language you're using. Since MATLAB is a high-level scripting language, that code is actually interpreted, which means that it's turned into things that the computer can understand through a two-step process. First, you turn it into some variant of C, and then you actually turn it into code that reflects the instruction set architecture of the actual microprocessor. So that's a compilation or a compiling process. But anyways, that's too much detail. Syntax is the rules of the language. If you got a syntax error, your code ain't going to work. So those are going to be easy to spot in general. So even when you're getting started, you feel like syntax errors are horrible. Oh, I have to remember to put a semicolon there, or I have to remember that I can't start a variable name with a letter. However, once you've kind of moved into coding on a regular basis, what you know is that semantic errors are actually the hard ones to spot. And the reason is semantic errors don't necessarily violate any rules of the language. A code with semantic error is free of syntax errors. And what that means is it will work. But the dangerous thing is it doesn't do what you intend it to do. So code with semantic errors, it compiles or it interprets, but it doesn't perform the intended function. So classify the basic properties of MATLAB using some of these attributes here. Open source versus proprietary. Well, you have to pay for a MATLAB license. We didn't, because Alamo Colleges pays for an academic headcount license. But in general, if you go to the workplace and you say, hey, I want to use MATLAB for this, if you don't have a license, you're going to have to justify to your boss why you want to pay for it. Versus comparable languages that are scripting languages like Python, those are open source. They are free. And there's a bit of a trade-off, as we'll see when we start working with Python, at least doing a little bit of demos later on in the course. There is more work on you because you're not paying for this package that you're actually delivering, which we'll define here in a little bit. Is it high level or low level? It is a high level language. Remember that when you differentiate programming languages, what high level versus low level means is how much do you have to understand about how the computer actually works in order to write the code. So how much does the syntax actually reflect computer architecture? We did an example. I just recorded Lab 3 in case you haven't watched that yet. We'll talk about, again, the idea that MATLAB is an implicitly typed language. And what that means is if you tell it to store like a variable containing an integer like 4, it will actually reserve all those bits corresponding to a double precision floating point number like we looked at in the first lab. So it's not very efficient. It's not thinking about how computer hardware is actually laid out. So that makes it a high level language. So generally speaking, high level language has syntax that's much easier to read, and it's much more forgiving versus low level languages that are closer to the hardware. You have to understand things about how the computer actually operates in general, things like memory management and so on. And because of that, your code is more efficient. And going back to that concept I was talking about in the previous question, low-level languages generally can be directly compiled into assembly language, which matches the instruction set architecture of the microprocessor. So what that means is the code you write can be converted into the ones and zeros that the microprocessor understands very simply, versus high-level languages usually have to be interpreted. They're converted down to a compilable language, and then they're actually taken into assembly language. Is it broadly used or narrowly used? This relates to some concepts we talked about in the actual first lecture. It is broadly used, and what we mean by that is that, sorry about that, there's an error I didn't see when I was typing these directly. This was a semicolon, so let me get that off, just in case anyone's just watching this and they're like, oh, I saw he has that answer. That is not correct. We'll modify it later. But it is a broadly used language. What we mean by that is there are lots of users all over the globe, and they're not just in engineering. They're not just in computer science. It is quite broadly used in finance, econometrics, and so on. So don't think like, oh, we're just using MATLAB. No one learns that. Just use any job search engine and see how many employment opportunities there are in the language. Is it an application, meaning an executable thing you actually define, like a text editor, or is it a programming language? The key is it's both. And that's the case with a lot of scripting languages, like even Python. When you talk about Python, people say, oh, it's a programming language. Well, what's the compiler? What is the program that actually converts the text written in Python syntax to something that the actual computer can understand. That is an application. And if you have ever worked with Python on the command line, you know that you actually type Python and then the name of the file. That's basically calling the application Python in order to interpret your code that's contained in that file. So hopefully that just kind of gives you some context of where MATLAB sits within the broader set of programming languages, since that is one of the learning outcomes of the course. What are the syntax rules for variable names in MATLAB? This also applies to any user-defined identifier, including your script names, your function names, and so on. They can only contain letters, numbers, and underscores. Remember that underscores are kind of used to give the illusion of a space if you have a variable name where you want to convey multiple words that are kind of combined together. Another way to combine multiple words together or give the illusion of it in a variable name is that idea of camel casing that I've mentioned quite a bit, where you use all lowercase letters, but you capitalize the first letter of whatever illusion you're trying to give of a new first word. In addition, even though they can only contain letters, numbers, and underscores, they have to start with a letter, and they are case sensitive. So what I mean by that is that if you go to MATLAB here and say I clear my command window, and I clear my workspace of all variables, I define a variable uppercase A as 2, and I say, hey MATLAB, what's lowercase a? It says, I don't know. It says unrecognized function or variable A. The red means this is a syntax error. Like all good integrated development environments, it says, hey, maybe you meant capital A. That's defined in your workspace. And that's showing you that the MATLAB language is case sensitive. Big A and lower A are not the same thing. So here we have some actual code. We want to assume that the following code is implemented in MATLAB. Remember, if you have a variable name, this is valid, it's a letter. We're going to assign it the value of. When we see the open and closed square brackets, we know it's going to be a matrix or a vector. If you look at the numbers inside the square brackets here, they're separated by semicolons. What semicolons do in the case of a vector, since these are all semicolons, is whenever the interpreter sees that, it goes to a new row. So it kind of stacks them on top of one another. So 2 starts in position 1, 1. And then when you see the semicolon 5, it's going to go to a new row. And then when you see another semicolon, it's going to go to a new row as well. So this is creating a 3x1 column vector, versus if you have comma delimiters, those go to a new column. So they actually stack horizontally, not stack vertically. So B1, 2, 3 is going to be a 1x3 row vector. Remember that the apostrophe operation, when it's applied to a matrix or a vector, of course, what it does is take the transpose. So if A is defined as a 3x1 column vector, the transpose is going to make that into a row vector. It will be 1x3. Now, what we have going on here is we're defining a new variable C, and we're concatenating it as the combination of B and A2. Remember that what the semicolon does is concatenate vertically. The comma concatenates horizontally. And you can kind of go back to our original definitions of row vectors and column vectors and see how that is. So the row vector, you can view these commas as basically concatenating the numbers horizontally, 1, 2, 3, versus the semicolons are concatenating the numbers vertically, 2, 5, 7. So what this is doing is trying to do a vertical concatenation of B and A2 that will be defined as long as the dimensions are consistent. So since B is basically a 3-element row, a row vector 1x3, and A2 is also a 1x3 row vector, you're stacking a 3-element row vector over another 3-element row vector. So after the concatenation, you'll have 2 rows after concatenation. And that is definitely spelled wrong, but it will be 2x3. And what you can do is actually just type this into MATLAB. And I just created a new script because if you paste this directly, you might find that because you're copying out of Word, the apostrophe will not paste correctly. Don't worry about it. Like this might show up red. Just delete it and type it again, and it will work. And then go to your command window and actually just execute that script. And then if you want to just verify everything, you see that A is a 3x1 column vector, B is a 1x3 row vector, A2 is going to be the transpose of A, so it's going to be a row vector, and then C is going to put basically in this case, the row vector B, 1, 2, 3, on top of the row vector A2, 2, 5, 7. So let's go back and answer the actual questions. So the dimensions of A2, again, it is 1x3. A2 is the blank of A. It is the transpose of A because of this apostrophe. Remember that you can also execute the transpose actually using the transpose operator. So in addition, like just showing you if I have B here, remember it's a row vector. B apostrophe is going to be a column vector, but also if I just type transpose B and pass B into the transpose function, I get the same thing. So that, and then specify the value of C 2 comma 1. Well, C is this concatenated 2 by 3 matrix that we have. So the 2 comma 1 value is just going to be the first element in the second row, which is going to be the first element of A2, which is going to be 2. And you can either, like, if I were you, I would write these out when I'm actually doing it on the test, or, you know, don't be afraid to validate your answers in MATLAB here, and you see that that answer is actually 2. So going back to the actual homework here, so this should say 2, not undefined. Again, unfortunately, when I recorded this video initially, I thought that was a comma, because like when you're looking at it in Word, it's hard to see the semicolon, and then I validated it in MATLAB, and I'm like, oh, that was a semicolon. So anyways, write a few sentences. We'll make this the last one of this video. Actually, we'll keep going all the way through. Write a few sentences explaining why you would group a set of commands within a script file and some best practices for writing scripts. So if you think about what a script does, it basically combines a bunch of commands that are all included in a related or single workflow. So like we've done a lot of examples of define, like you want to create a plot. Remember that RC circuits lab, the transient response that we did. In order to generate that plot, we had to compute a time constant. We had to define the time vector. We had to define the current vector. We had to actually call the plot command, and so on. So those are a bunch of commands that are executed related to the workflow objective of actually plotting the transient response of the current in an RC circuit. So that's why you use an actual script. What are some best practices? Well, you want to use semicolons. Do not display intermediate calculations on the command window. Remember that the user, generally we're going to only want to show the user the actual final outputs of our script. So like in the case of like where we needed to compute the time constant, we don't necessarily want to show the user that. So semicolons will suppress that output from going to the actual command window. And then comments make code readable, really for two people, for you later and for your collaborators now. And sometimes the more you code and the older you get, for you later, sometimes might be the next day, especially as you develop more and more skill with coding. Oftentimes you will do things very cleverly in a very small amount of commands, and then you will out clever yourself the next day when you have to go back and look at it. So here we go. Let's look a little bit at colon notation and linspace notation. So assume that the following code was implemented in MATLAB. We're defining a vector t using colon notation. Remember, this is start, step, and stop. This means start at 0, step by 0.2, stop at 2. So how would that vector actually look? Well, it started at 0, 0.2 after is 0.2, 0.2 after that is 0.4, then 0.6, and so on all the way up to 2. And then T2 equals linspace 0, 5, 100. Remember that the syntax for linspace, or you can just look it up if you want, that is the start value of 0, stop value of 5, and then 100 evenly spaced elements in between. And if you remember back to your syntax there, it is a row vector, actually. So in the questions here, what is the value of T2? Remember that MATLAB is a 1-based index, meaning that the first value is T sub 1. So we're indexing here. T sub 1 would be 0. T parentheses 2 would be 0.2. So that's going to be the second value in this array. So for this answer, it is just 0.2. And then true or false, T is a column vector. No, colon notation by default is going to yield row vectors. So this is false. And then specifies the size of T2. T2 was defined using the linspace function. This is start, this is stop, this is the number of elements. So it's gonna have 100 elements in it. The question is it 1 by 100 or is it 100 by 1? Remember that linspace generates row vectors, so it will be 1 by 100. And let's actually kind of validate this for ourselves. Let's just define T here into MATLAB. And then let's look at T1, that should be 0. T2, since the step size is 0.2, should be 0.2. That is correct. Now let's go and let's grab and create T2 using the linspace operation. And if you notice here, the size of T2 is actually going to be 1 by 100. So it's creating a row vector with 100 elements. If you look at the first element, it will be 0. And if you look at the last element, it will be, sorry, not T25, T2100. That will be 5, since that is a stop value. So let's go back to the actual homework here. Actually, let me see where I'm at with my video, just so I don't make this too long. We're at the 15-minute mark, so I'll start recording a new video for the rest of this solution.